Hi. So I missed your few questions because my machine got just rebooted. I'm back. All right. Are you able to hear me now? All right. I'm extremely sorry for this. It got just rebooted just like that. All right. So I was telling you about how to test. So first you create these variables, declare these variables, map driver, reduce driver, and map reduce driver, so that you can test mapper reducer separately and then together both of them without having to upload on the server. And then you write your test mapper method and test reducer methods, whatever test case you want. You just create those functions, okay, and then get it executed. So each every time you execute a driver, you can add separate input data, and then you can add I mean, the way you will be inputting the data is in the pair format, and one in the key value pair format. And then once it is done, you can, after you run it, whatever result you get, you can test it the uh, against the expected value. All right. And running it is very straightforward. You can basically say things like run as JUnit test. Okay, so it doesn't connect to the server, it just runs it offline. Here these two test cases are successful. This one has been purposefully left, okay, and I have marked it failed so that it shows that something has failed. Okay, it shows that out of three runs there has been one failure. Okay, three out of three runs. All right, now question from Randhir is, okay, question, let me just open. All right. Question from Randir is, how do you verify the test result? It is based on the logic you pour in. Like for example, let's say here I'm passing 1 as the key to my mapper, and this is the value. So since key was supposed to be given, I've provided that, but it is not required. Okay. Now, while we run the MapReduce driver, okay, it'll give us some output. This output is in the form of key and the value array. It's a list of key values. Okay, it's a list of pairs, meaning key value pairs. And then you can check here things like whether there are 11 keys in the output. So we are comparing output.size to 11. All right. Similarly, you could also iterate over the list, collect all the data, and test it against fixed defined output. Okay. So that's how we generally test it. Okay. So we know manually that how many words are there, right? In this, how many distinct words are there, right? So if I type here Giri again, it should not increase total number of keys, right? That's what we want to test. So we can simply test either individually, or we can run the whole thing again. Okay, it says it is successful. But if you put something else here, okay, that means now there will be 12 keys in the output because we are doing the word count. Okay, because there are 12 words, it says that expected 12, you can see on the left hand side, but it was expected 11, but it was 12. Okay, this is how you keep on testing. You prepare the input data set, and you test the actual test the code against it. You define all of this upfront. So programming is not only writing the logic but also writing the test cases. Okay. All right. Are you able to hear me? All right. Good. So that was about creating the test cases. Let's take a break for 10 minutes and come back at 10:11 p.m. All right. Hi, I'm back. Should we start now? All right, great. All right, so let's start then. All right. So, did I miss your questions anywhere? All right. So, before we move on to input splits, do you have any questions for me? Yeah. Now, Sushant's question is, what are the uses of test class? Test class is the objective of test class is quickly test your logic. So every um, case should be covered in your test case so that it can be in future if somebody is changing the code, it should not break. Okay, it's impossible to manually test everything again and again to validate whether the new logic is right or wrong. Is it breaking the previous cases? Okay, so instead of manually verifying, if you create the test cases, there would be many more uses. So I would strongly recommend, if you are not aware about the testing methodology, just understand how do we use JUnit and why do we use JUnit. Now Sridhar's question is, do we have varchar data type and bigint? Okay, so instead of a varchar we have text. Okay, and bigint is basically long writable. Okay, that's what we did. So Sushant's question is, in real world, it is for QA. Not really. It is for SDET. SDETs are different engineers generally, or in every team there are engineers who are SDET. But but in truth, this should be done by developers. Okay, there are QAs in practice who do the manual testing or who do the black box testing, external testing, but QAs can never write the test cases which are great. Okay, because they do not, because they have not written logic, so they have not thought about the edge cases. Therefore, most of the unit testing is done by developers. Okay, so uh, unit testing is done by devs and SDETs. SDETs are software development engineer test, and most of the manual and integration and manual testing, integration testing, and black box testing is done by QA. Sridhar, I did not get your question. Was I not able to explain? We have varchar, yeah. Varchar equivalent is text and bigint is long writable. That's what we do. Alright. So while converting the data type, we are testing the code here. Yes, we are testing our mapper slash reducer code, not the driver. Please note this. We are not testing the driver. We are only testing mapper and reducer. Okay. So okay. Sridhar's question is, does long varchar data type exist in Hadoop? I do not know what does it mean by long varchar. Is a single data type or these are two data types? What does it store? Okay. So maybe yeah. So I mean, bigger question is that what is it that you are trying to store in this? Yeah. What is it that you want to store in long varchar? So what does it mean by long varchar? I'm not a DBA guy. And allows storage of character string with a maximum. Okay. Okay. Yeah, yeah. So long varchar also is equal to the text type. Okay. In Java, because it's a automatic memory management, you don't have a size of a character array, which is string or a text. There is no size limitation on either. Okay. Therefore, varchar or long varchar, it's the same thing. Yeah. Okay. So one string object, we could say new text, and we put in some data here. So whether this is 1,000 characters or 1 million characters, it's okay. Okay. So yeah. So while defining a key, it could be anything. Great. Great. Moving on. All right. All right. I hope I have not skipped anybody's question. Let me start with the next point. All right. All right. So we always talked about HDFS block, where our file was ruthlessly split into into blocks of size 128 MB. The last block was generally smaller than 128 MB. Okay. So our blocks were split at the boundary irrespective of where that boundary falls. Right? Let's take a case of this scenario. This diagram and the example does not correspond to the same problem. It is basically the okay. It's basically different two different examples. All right. The diagram corresponds to a scenario where you have three blocks, one block, two block, and three blocks. Okay. Now there are five lines. Imagine the first block contains five up to five line. This fifth line is on the border. Half of the border is on the left hand side in the block one, and half of the border is on the right hand side in block two. Now, in the block two, you have some part of five and some part of nine, while six, seven, eight is completely inside the block. But What if the what if what would happen if the line, imagine there are this line is broken into two like this. Okay, so in your map function, as we told again and again, that the map function receives the line, right? So will it receive the line number 5 completely, or will it receive line number 5 in two parts? Anyone? Completely, right? And who does this completion? Mapreduce or HDFS? Wrong. It is done by Mapreduce. Okay. Now I'll explain to you again why. All right. So imagine that word.txt, our the one which we have been dealing with so far, the big.txt file. Imagine it has 11 lines, and these 11 lines are broken into three blocks. Now, if you get, and as I was telling you, our map function will be executed near to the data node. So Hadoop has to prepare the lines. Before executing your MapReduce problem, it has to prepare the lines to be given to your map program. And how does it do is, it basically transfers some data from across the boundary to complete the line, and this is done by Mapreduce. Mapreduce has a concept called input splits. So this, in those cases, what it would do is, first input split would receive the complete 5 lines, while second would receive complete 6, 7, 8, 9, these four records, 4 lines or records, and then the last one will get 10 and 11. Okay, this mechanism of translating the raw blocks into input split and the records is done by input format. Okay, this is done by input format. So there are three things we talked about: a record, input split, and input format. Input format converts, it's a program which converts the raw block into input split, and input split is a collection of records, and a record is something which is fed to your mapper one at a time. Okay, or you can say your mapper is executed against a record at a time. Okay, now what, this translation from raw block to a split is done by Mapreduce. Okay, and now let me go back for a minute. You can see here, when we talked about here, we have not specified anywhere what is the data format. So by default, it considers the input file into the text format. In case you want to change that behavior, if you want, instead of one line at a time, you want 20 lines at a time, you can use some other input format class. Therefore, the job of translating the blocks into the text is not done by HDFS. It is done by our MapReduce program, or it is done by this class called input format. Input format will be given the block of data and it will convert it to records. Sushant is saying it is like the bad job. No, it will happen in real time. Whenever you want, it will be done part by part. So parallelly, on one hand, it will be preparing records. On other hand, it will be running your mapper class. Yes, it is like a library. All right. So hope the problem is clear. What is the relationship between input splits and HDFS block? So from here to here, okay, they'll be very confusing. Pawan's question is, if a boundary is falling near the end of the line, it makes sense to transfer part of the data line from another block. How about if bu- boundary falls at the beginning of lines? Okay. So if if boundary is falling at the beginning of line, everybody is happy. There will be no transfer involved. Okay. Yes. Good point. So Naveen Gupta is saying, how about XML file or JSON file, not text file? Very good point. Now here we were pretty happy that we were able to easily distinguish and prepare the line by line, right? What if your data is in a binary format where you want the boundary to be prepared custom way? In those cases, or your data is in the XML format and you want the complete node together. Similarly, you are handling a JSON object and you want the whole JSON object in a complete way. In those cases, this standard way would not work, and therefore you would require a custom input format. Okay, you would require a custom input format to deal with these kind of input splits. Okay. Okay, so Pawan's question is, if a block boundary is falling near the end of line, it makes sense to transfer part of the line to another block. Yes. How about if the border is falling at the beginning of the line? It means, yeah. So idea is, the reason why it happens so is the on every block, the reading starts parallelly. When we try to execute our MapReduce program, it has to, the whole system starts preparing the input data. The whole system on every node parallelly starts input format. Okay, so you can imagine that there are three readers reading these three blocks. First one reading from here, second one reading from here, and third one reading from here. This is happening on three machines parallelly. Okay, and now on three machines, the logic is, if you don't encounter boundary, you keep on throwing data to the other node. If you don't encounter boundary, you keep on throwing data to the previous node, or you keep on putting the data aside because the other node is going to come to ask you. So since this guy is another case, because he will see the boundary and will start. Okay, for him the boundary is here. He'll start consuming the data, and then for this guy who is on this node, he'll see that, oh, the boundary is not yet here. Currently the boundary is not here, so it will start skipping the data and transfer keeping it for the another node, and while searching for the boundary, and the moment it finds the boundary, from here onwards it will feed it to this guy. And then also, if the boundary is not met, it will keep on asking the next block to give it back. Similarly here also, if it was very simple, as in there is one guy, one thread reading the same file, the life could have been much easier. Here these all machines, the input format on every machine is running parallelly. Okay, let me take a step back. Let me uh, go to the beginning and explain to you the problem. Okay, so we have got HDFS, which does not know what is there inside your data. So, and to facilitate all kinds of things which we discussed earlier, resilience, reliability, and backup and breaking it. So it breaks the file into blocks. That is part of the design, and these blocks are kept in HDFS. HDFS knows nothing about your data. Now, when you want to do something with that data, instead of bringing the data to a central node, we want to do it then and there on that particular node. And what we want to do, what we want to do on that data is expressed in terms of maps and reduces. Okay, is expressed programmatically in terms of maps and reduces. And when we run the maps and reduces, now maps needs records to process, right? Whatever logic you write, it would need the data to be formatted. Data could be in XML, data could be in JSON, data could be in some other format. The data, that blocks, raw blocks, have to be translated into the records. These raw blocks may not be good enough, because on the boundary conditions some of the data might have gone to the another object. Therefore, to translate the raw blocks into records, okay, records means a line. In case of our plain text processing, record could be a database row. So we have to make sense out of this block of data, right? Now, we cannot do things like we can parse all of this HDFS, save it in a single file, and be happy about it. That is not possible, because if you try to do that, the whole purpose of HDFS is lost, right? The whole purpose of distribution of data, utilizing so many machines to do your things, is lost. Okay, while we are running our logic on so many machines, we already got the mileage of having so many machines together, right? We are looking for one more advantage. That advantage is data locality. Instead of transferring this mammoth amount of data to a single node, and then to different node or to different machines, and trying to process that, okay, instead of doing that, we are trying to run our logic then and there, and the raw logic cannot be run directly, because the data is in the shape of blocks, and these blocks do not make sense to your program, right? When we are dealing with word count, for example, how would you feel if we just give you the byte array, right? We just gave you a byte array saying, here is your data, this is what we found in the block, please do the word count using this byte array. Now this byte array, some of the words which are at the end of it, might be the word at the end of it might be sliced into two. The characters could have been sliced into two. So it will be too much of hassle for you. Okay, there'll be too much of hassle for you. Now, either you could write things like talk to other mapper node, get the data from there if my record is not complete. So that kind of hassle is absorbed by input format for you. Okay, so that whole mechanism is called input format. Pavan, did I make sense to you? So you might be wondering, when this is just a small block, what if this boundary was here? Why would we transfer the whole 9 into the left hand side, not right hand side? You will understand this very soon. All right. Okay, so input split, Hadoop divides input into pieces called splits, or Hadoop loads block into input split. So input is converted into splits, and these input splits contain records. For each input split, a task is launched. Mapreduce mapper task is launched for each input split. Okay, so that the class, or the class you created called stub mapper, will be instantiated for once for each input split. One mapper instance per input split. Split consists of many records. In our case, since we dealt with just the plain text file, the record was a single line. Okay, so our input split composed of many lines. Mapper runs on each record of the input split. The map function which we have had in our Java code will run once for each record of the split. If you have small splits, there will be two. If now the question arises, how big our input split should be? It's a very common question. Since we are talking about translating blocks into input split, okay, translating blocks into input split, it makes sense to understand that how big our input split should be. One is, if a small input splits are there, if we created too small input split, what would happen is there'll be too much of data transfer. As I was telling you, when we create input split, if there is extra data, it's transferred to the previous node. If it is lesser data, it requests the other node to send it to. Okay, so if you are creating too small input split, there will be too much of overhead, platform overhead, network overhead. Okay, if there are too big input splits, then again imagine that we have one input split equal to the size of 4 blocks. Now remaining 3 blocks will have to be transferred to one single node. Let's say if you are computing the signature, if you are computing the signature of a file, to compute the signature, you want the whole zip file, a whole file on a single node. Or imagine that your data was zip file and you want to unzip this zip file. You had a zip file, you uploaded that zip file to her HDFS. Now imagine what happened to the zip file. The zip file got sliced into portions, and if you have any experience with unzipping a zip file, you would know that to unzip a zip file, you need all the parts of that zip file, right? You cannot unzip the data without having all the parts together. Therefore, if you zip the file with the normal zipping algorithm, what would happen is every time you want to process the data inside zip file, you will have to unzip, you'll have to bring all blocks together on one single node and effectively unzip the whole data. So you can see that in case your input split is such that it demands all the blocks, there will be too much of network overhead. The whole objective of data locality will be lost. Therefore, the input split is generally governed by your requirement. What is it that you're looking for? Are you trying to compute the average bit rate of your MP3 file? Or are you trying to compute the signature of your file? Or are you trying to just read line by line? So, based on that, you will prepare the input split. Okay? Based on that, you will prepare the input splits. If you create too many input, too big a input split, there will be again a lot of platform overhead. Good size of a split tends to be equal to the block size. Okay, so most of these input formats which convert blocks into input split, they're designed in a way that the input split prepared by them is very close to the blocks. The size should be near to the blocks. All right. Now, each input split is divided into records. A map function is applied on each record. A record is a logical entity. Analogy of a record is in RDBMS you have rows. Similarly, input split you can think of sections of table. Okay, parts of the table. If the full HDFS file was a big table, it was a table, then input split are subsets of the rows. Okay, and each record is a row. Input format creates records. All right. Now, in 99% of the cases, the existing input formats will be sufficient for you. Okay. For example, you have this is the default one. This is the default input format, which basically handles the text input format. Here, the new line is the delimiter by default. Each single line is the record, and the new line is the separator expected from the raw text as as separated between one record to another. So you can change the delimiter to something else by setting this property in the context. You can say that you're looking for some other delimiter by specifying this. Okay. In case your file is not separated by /n, which is new line, in those cases you can use some other delimiter. Now there is another input format called n-line format. Right now in our default way, our map function got only one line at a time. Sometimes you want multiple line at a time. Let's think about character counting. Character counting can be done if efficiently if we try to do it over multiple lines. Okay, so in those cases you could use n-line input format, and this n-line input format can be very effective in few situations. So, so this is another input format, and you can change the input format. If you look at your Java code, you can change it by setting input format. Also, input format can be set using your streaming job. Streaming job provides you a way to set the input format. All right. Veena is saying, are we going to do examples of MapReduce for other file types too? So far, I have not prepared one. Okay, but I can think of some examples. Okay, I had some requirement from some industry where they were trying to process gigabytes of XML file. All right. Next is the fixed length input format. Okay, fixed length input format which contain fixed length records. Sometimes when you're dealing with specifically the binary data, such as let's say your MP3 music or let's say your tar files, so they have fixed length records. Or sometimes you are dealing with a legacy input where each record is supposed to be of the fixed length. If it is ended before, it would put some special character for padding. Okay, so in those cases, you could use something called fixed length input format, and this is again part of the main library. You can say things like, if your file is in the format of fixed file format, not comma separated. Okay, so you could say fixed length input format. Okay, you could say things like this. All right. and and you could also change the you could change the number of lines that it should consider, the size of the file record it should consider is based on this. It can be done based on this. Okay. All right, so you could say conf, and then you can say i'm looking for I'm looking for each record is supposed to be 100 character size. Sounds good to you? All right. So that way you can set how big your record is and then it can take care of that. In our plain text file in the word count, we were basically our records were separated by /n. Here the records are not separated by any character, just that they are fixed size records. All right, so figuring out records from raw data from the bytes is the duty of input format. Okay, now there is another input format which is called key value text input format. If your file is in the form of key value, okay, if the file are if the file are in the form of key value and is a plain text file, then you can use key value text input format. Okay, files are broken into lines. Either /r or /n are used to signal the end of the line. Each line is divided into key value pairs by a separator byte. Okay, if no such byte exists, the key will be the entire line and the value will be empty. Okay, otherwise, and you can set the default one, the default character that separates key and value is equals. You can change this by setting this variable in the config. Okay, so you can see that we could do key value input format here. You could do key value input format here if you are for sure. Okay, okay, so yeah, you'll have to use the you'll have to do conf.set and then you have to do these variables. Only then it'll consider it. Okay, now moving ahead. All right, now sometimes you want to deal with the binary input data, and interestingly, most of the binary files are tackled in a similar fashion. All of those binary files have something very common. All of these binary files have header and then the body. Okay, so let's take a case of music file. Music file has a header and the body. Similarly, the movie file has a header and the body. So for those dealing with these kind of files in general is very well done using some input format called sequence file input format. Okay, let's say you are dealing with a zip file, you are dealing with a compressed file. That too can be very well dealt with using sequence file input format. A sequence file is the flat file of binary key and binary value. Okay, and it has got a header containing the details about the data it's carrying. Most of the zip files, tar files, jar files can be converted into sequence files, and that is the best way to deal with most of the binary data. As a thumb rule, if you have lots of small files and you want to store them in HDFS, you should just zip them together, convert it into sequence file, and then while processing, you can use sequence file input format. Okay? Each record will become the each record will become the binary key value, and that will be given to your MapReduce. Alright, some notes regarding MapReduce here. Okay, you can directly read file inside your mapper. You can directly read files from anywhere using file system. Okay, You can also read files from HDFS inside your MapReduce code. Nobody is stopping you. Here you have to give the URL of the file. All right. Now, sometimes you want to have a format such that even the compressed data can be very well stored in HDFS. Similarly, it can be stored in HDFS as well as while we processing the data, we should not need to transfer all of the data to one node. Right? As I was telling you earlier, that when we have to unzip a file which has been split it into blocks, ideally we will have to transfer all of this data to one node and then unzip it. You don't if you remember our those days when we had these multiple floppies, or where when we used to split our zip file, we have to insert all the floppies one at a time, and then only it will be able to unzip it. Okay, but lucky for us that today there are compression formats which can compress the data in the form that the data could be unzipped in parts. Okay, data can be unzipped in parts. Okay, in those cases, people, instead of storing data in zip format, standard zip format, people use Aljado or gzip splittable. Okay, so while taking a decision where you have either very small files or lot of plain text file, consider using gzip splittable format. All right, or Aljado format. Aljado is another powerful format specifically designed with the cases where we might have to unzip the data in parts. We want to store the data, but when we are processing, we should not be needing all the blocks of the file at the same time at the same node. Okay, so that's what is Aljado format. So while saving the file, let's say you are building this great website which is storing all the users icon photo, and every icon photo will be hardly 1 KB. Therefore therefore one block will be equal to 128,000 block 128,000 photos, right? So it makes sense to couple these files into ggp splittable or Aljado format if you are planning to store such file in HDFS. All right, here is a simple architecture of input format. Input format is fairly complex technique. Generally, you would not need to customize, or you would not need to write your own input split format. You don't need to create your own input format. But still, if you want to create, here is a simple strategy. Okay, first you create something called input format. There you will have two functions. One is get splits and other is create record reader. Get splits returns the list of all the input splits based on the job context. While each input split is made up of few things. One is locations, string locations, as in where are these where are the records on the actual file system and how big is each input split. Okay, so that is the job of input split. Now that is the definition of input split. So get splits will give you the list of all the input splits. Ideally, this you can also override this. All right, now The first thing which input format has to do is create record reader. You have to create a record reader. The record reader would get the input split, and it is supposed to convert the data into records. Okay, so first the raw data is converted into input split. That is the duty of get splits. Then, given an input split, you are supposed to convert that into records, and that is done by create record reader. So input format, when you extend, you can use you can override any of these functions. All right, so that was, I'll show you examples here. So we have defined our own custom file input format. This is our custom file input format. Or you can see there is a custom record reader. Or there was one more thing I had done here. Yeah, I think there is one more project over there in the examples. There I have written the custom reader. There I have written the custom reader. Okay, so you can, this is easier for you. Okay, this will be easier. So if you have to create your own input format, you can just simply extend either the input format, or you can extend existing one. So here we are extending the text input format, and we are only overwriting create record reader. We are not changing the behavior of input splits. Then inside the input, this record reader, we are only, basically we are extending record reader here, and inside this, we, when get progress is asked, we override these many methods. Okay, and in the initialize, we basically start the process of creating the records, and then and then whenever the user is asking for next key value, or the framework is asking for next key value, we are returning bunch of records rather than only one record. Okay, take a look at it. It's a fairly complex code, and most of the input split examples are actually complex. So you, if once you go through this stepwise, you will be able to understand how to create records from input split. All right, so this is one example which you can utilize for understanding how to customize the input format. Okay, all right, any questions at this point of time? All right, so I'm guessing that you did not understand things. That's why I did not explain things correctly. That's why there are no questions at the point of time. Are you with me? Arjan, Ganpati, Naveen, Pavan, Randhir, Saryu, Sridhar, Sushant, Veena. All right. So yes, I agree it was little complex, but if you look at the example which we have given, you will get the idea. Okay. And for that matter, whenever you are customizing things, let's say you are writing a JDBC driver, it'll be a little complex. All right. Okay, so these examples are available here in the course page. You can go here and download. One is not this. You can download this and this. There are two projects. I showed you two projects. One was this SG1, SG test, and other was TRG2. These are the two tests. You can download it from here. Okay. So there's a question from Naveen. Yes, I do have solutions to the last exercises. Okay. But I'll just review your exercises in isolation. As long as it's giving the results, that is the solution. Okay. There is no, there's no single solutions to the problems. Okay. We need to get used to uh, figuring out the overall, validating your solution based on the test case rather than through me. Okay. So yes, I do have, yeah, and maybe at the end of session, once the course finishes, I will, once you submit your exercises, I can share that with you. Okay. Because I expect the solutions, the complete solutions from you. All right. All right. So there was a question from Veena. Veena's question is that where can I find the list of already existing readers? All right, that has been a little difficult to get the list, but probably the one which I have mentioned here are good enough to start with. Okay, or moreover, you can say JSON input split Hadoop. Okay, JSON input split Hadoop. Okay, custom input format reading this, and yeah, so here it's very difficult to get it done. Okay. So there is something called whole file format. So there are many open source projects which have been created in order to provide input formats. So you'll have to do a little bit of research to figure out which input split is good enough for you. Okay. The one which are there in the core, I have shared as part of the project. Rest, whenever you are working on something, it will involve doing a little bit research. All right. So, all right. For example, there is something called XML input format. You can see XML input format. So here is the input format. Okay. So let's see. Yes, it is for that only. You can see that. All right. So we talked about text input format and line input format, fixed length input format, key value text input format, sequence file input format, and then we also talked about these splittable files. Sushant, could you just drop me an email? I think that will be better. All right, that will be better. Okay, and if required, I'll just put it on the forum for everyone else. All right. Now that was about input formats. Okay, let's just do a little bit of recap what happened. So when the reducer was single, again, I'm going back to the beginning. So HDFS input block was converted into a split, and then that input is split. Against each record, your map functions were called, and whatever key value were gathered were taken to the merging, and after merging, when all values of key, each key has gathered together, then reduce function was called on each key, and then whatever was the result was saved onto HDFS. Okay. Now now if there are multiple reducers, this is what happens. So there is input split. For each input split, we generate the key value pair, and here the sorting also happens. Now the question is that this data will be carried to two different nodes, and on what basis we are splitting these into two buckets. Okay, who is deciding which key should go to which node, which key should go to which reducer? Who decides that? Okay, by default there is a logic of, based on hash code, it is decided whether a particular key goes to the first node or a particular key goes to the second node. Okay, but if you want to customize it, how do we do that? Okay, that's where the partitioner comes into play. There is a default partitioner. The partitioner is the one who decides which key goes to first reducer, which key goes to the second reducer. So it is the partitioner that is going to decide that part. All right. So this partitioner, you see the age partitioner, which is extending the partitioner. It's deciding whether a particular key goes to first reducer or second reducer. Or let me take a step back. Let's say, let's take this example. Where is our file? All right, let's just try to log in into h1.this. All right, so where is my partitioner? Chaining custom partitioner. Yeah. So you can see that there is this partitioner here. What it does is, all right, let me define the problem first. So where was my yeah. So here did you see that not this one. Did we run it earlier? Yeah. So you remember where we were generating the output here. You can see that although these part 0 and part 1, let me open two Hue browsers, then it'll be far more clear. All right, so this result we got when we counted the words with two reducers. You can see that this is the part 000, and this is second one is the part 001. Okay, now this one contains 00, 002, 00, sorry, 002, 06, 100. These are the words. Okay, these are the words because the text file containing numbers also. Okay, and here also you can see that. Now if we concatenate these two files, part 00 and part 001, what would happen is the outcome will not be ordered one. It will not be a sorted outcome, right? It will not be a sorted outcome, because you can see that it needs to be merged. These two files need to be merged in order to get the result. Although individually the words are sorted 005, 001, and you can see that the words are sorted. You can see 16F, 16TH. The words are sorted, but you cannot merge these two files together so easily. We'll have to sort it again, right? Now, in order to generate the output, which is such that that if you just concatenate the two, it should become a single file, and it should be sorted. So what you would have to do, you'll have to define a partition. You'll have to define all the words which start with J or lesser should go to the first reducer. All the words that start with above J should go to the second reducer, and that's where the partitioner comes into play. This partitioner says, given a key, I will decide to which this key should go, whether to first reducer or the second reducer. Alright, so let's try to run this step driver this time. Okay, so let's define our partitioner. Okay, and we are defining number of task 2, and then let's have a look at step mapper. Okay, in step mapper we are cleaning the data. Alright, now let's try to do export. We are exporting jar, and we are say sg advanced Mapreduce. Okay, that's the file name which we have created. Let's copy this data to, okay, so let's copy this data. It is S5665. Alright, now we have logged in into this. Alright, so here we will do the copy scp scp scp. What was the downloads? Alright, and s5665 at h1.cloudxlab.com colon sgiri. So we have successfully copied it. Let's go into my folder and then try to run the newly created Hadoop jar, and I say sgamr, and then we say what, sg dot stub driver. Yes, so we are doing right thing, data mr, and then we say input data mr, and then we say word count, then input, and sg, and we say 8th November 1, or let's say 2. Let's see it gives some output or not. Seems to run. Alright, mapper is running. Alright, let's parallelly observe what happens here. All right, so it has finished the work. Okay, it has finished the work. Now you can see clearly all the numbers are on zeroth side, while all the things which are greater than k are in the first part. All right, so the partitioner decided which key goes to which reducer. Does it make sense to you? Yes, part 00 and part 001 are the output of the. Vina's question is, how did we decide number of reducers? The simple thumb rule is, if your reduce phase is taking too much of time, you decide on more number of reducer. Here, number of reducer is decided by us. All right. Sounds good to you? That was partitioner. So partitioner decides which where do we send the keys to? Okay. So how many reducers? By default, one. If there are too many reducers, effort of shuffling might be high. If too few reducer, computation takes time, and you should tune it to have total number of to tune it to be equal to the total number of slots. We've already discussed that part. Did we pass number of reducers to the driver? Yes, I'll show you this. So you go to the driver. This was the driver. You can see here we pass number of reduced tasks. All right. All right. So sometimes before one node sends the data to the reducer, we want to do some sort of summarization. We want to combine the data or compress the data before it goes to the mapper, goes to the reducer node, right? Since after it has finished the work on one node, only then it is shifted to the reducer. So if you want to do something to this data before sending to the reducer, that is what is known as combiner. Okay, that is what is known as combiner. Okay, so if you have two nodes, node 1 and node 2, and you have after the map, there will be lots of key value pairs here itself. Intermediately, combiner will convert them into a single key value, and then partitioner will partition that into reducer. You can see that. So so combiner runs on the same node after map has finished. If you remember our letter count problem where we were counting number of characters, if we had some way to do the letter count after all maps have finished on a node, then we could have been really happy, because then we'll have to transfer only 26 numbers, not the full data, right? That's where the combiner comes into play. So combiner runs on the same node after map has finished, processes the output of map, helps in minimizing the data transfer, does not replace the reducer. Okay. Okay. So Veena, which part did you not get it? All right. So San's question uh, is combining not just done by Hadoop? It is done. It is done by Hadoop. But if you want to run a custom logic while combining the data, then you can run that custom logic. Instead of Hadoop just taking all of the output of the mapper is just sending to the reducer, you can put in your logic such that your logic runs before the data is sent to the reducer. Okay. make sense to you, Randhir, Sushant? Okay, so question from Sushant is how can combining logic help in real world? Can you give an example? Let's take a character count problem, okay? We are counting character, okay? Now when we count the character and what we did is we spit it out key 1 value 1 kind of output, right? So we are saying A dash 1, B dash 1, C dash 1 and so on. If there are a billion characters, if there are billion characters, there are billion keys, right? These billion keys will be transferred to the reducer node, right? Reducer task. And this reducer task, this will be over the network. Now, if you do a combining on the same node before it gets shifted to other node, then it will get compressed. Okay. So reducer combiner is more like reducer running on the mapper node. It's a local reducing. All right. So although when we do character count, each node is just supposed to send only the character count of 26, right? 26 numbers. But because of mappers, because we were running mappers against each line, the total number of characters will be too huge for a big data file, right? Therefore, the combiner will be lifesaver in such scenarios. Susan's question is, will it also sort? No, the sorting is anyway done default by Hadoop. Okay, after the sorting has finished, you can see here. After the sorting has finished, after the map reducer, you can see that the combiner is executed, and then the sorting will happen in parallel. Okay, I'll show you the sorting will happen in parallel when combiner is being executed. Now, question from Randhir is: can we write partitioner or combiner using Hadoop streaming? Yes. You can take a look at their examples. Okay. So question from Sridhar is, for the word count, the array size will be 26 if we use combiner on each node. Yes. So the data that will get transferred from each node to the reducer node will be of 28 characters, 28 numbers, 26 numbers, not 28, 26 numbers. All right. So that's about the combiner functions. Now there is one little catch. There is one little catch about combiners. Combiners need to be combiners need to be their signature need to be same as reducer. So as a matter of fact, if you notice here, I will show you one combiner example. So it will extend the reducer. Okay. In general, whatever reducer we have, we can use that as a combiner. If you see our step driver, you can simply see that we can say job dot set combiner, and we could say stub reducer dot class. Sounds good? That's it. So we could actually use the reducer as the combiner as well. All right. The only catch is this reducer need to be kind of need to be a function which can be applied again and again. Still, the result should be same. Okay. This is little tricky. For example, So not every combiner, not every reducer can be a valid combiner. Okay, not every reducer can be a valid combiner. There are only selected few combiners which can be the selected. There are few reducer which can be a combiner. Okay, so if you remember, what does a reducer do? Reducer combines multiple values into single, right? What does combiner do? Combiner combines all the values into one, right? Now the only difference is with combiner is no matter how our combiner is applied, the result will be the same, no matter how many values at a time. For example, let's say we are trying to compute the maximum of these four values: 0, 20, 10, and 25. Let's say this is what we are trying to do. Okay, we are trying to compute the maximum of 2. Now, the combiner would might get first these two values only, or then another instance of combiner might get only these two values, and then the result of the combiner when it was applied on both might be passed to another combiner. So the maximum of this thing could also happen in such a way that first maximum of 0 to 20, then maximum of 10 to 25, and then maximum of the total. Okay, so what I'm trying to say is combiner is being called while the sorting is running in parallel, right? Therefore a combiner is called many times, i- unlike the reducer. In reducer is called only once per key, but combiner is called recursively multiple times. Okay, so to combine these values, maybe the combiner is called first on these two values, then this, and then this. Okay, or combiner might be called first on 0 and 10, and then 0 and 25 to 20 and 25, and then overall. Okay, so you can see that in case of max, it is correct. The value, no matter how we apply a combiner, the result is 25. But in case of average, the answer is not correct. The average, if all values are together and you compute the average of these four values by summing and dividing by 4, you will get 11.25, right? But if you do average of two values at a time, and then next two values at another time, and then whatever is the average of average, we compute that, the result is different. Therefore average cannot be used as a valid combiner. Average cannot be used as a valid combiner. That is the only catch in the scenario. Now, Sridhar's question: if we use two reducers, how you can determine which reducer we can use on specific node? No, we cannot have different logic on the two reducer. The two reducers would have exactly identical logic. We cannot have two functions which are serving as two reducers. It will be the same code that will be run everywhere. We cannot have multiple piece of code running as mapper. Okay, it'll be the same code replicated over the network. Okay, similar is the case with combiner. Whatever logic you define for combiner, it will be common for all right. I think, Sridhar, I did not get your question. See, this question is, we can use reducer as a combiner. Yes, only if reducer satisfy this kind of property. If a reducer is computing average, we cannot use that as combiner. You'll have to create separate class then. Right? Question from Sridhar is, if we use two reducers, how can you determine which reducer we can use on a specific node as combiner? We cannot ever say that on a specific node use this. No. Okay? While we launch the process, only then we can, let's take a case of step driver. While in the driver itself, we are saying that this is my reducer class, that is my combiner class. We can choose to have some other combiner. Okay, we can choose to have some other combiner if we want. Okay, same is the case with reducer. So here we are passing on the code. Okay, we are passing on that here is my reducer, here's my combiner. So wherever it's being called as combiner is being called, this code will be called. We cannot customize it. We cannot say something like, okay, set combiner class on node 1 it is this, or node 2 it is something else. No, we can't do that. Okay. All right, was I able to answer your question, Sridhar? All right. All right, see you tomorrow. Have a great day. Bye bye. All right, I'll have to hang up now. Bye bye. Have a good day.